transformations with transformations with exponential functions. Okay, we're not going to go through and do all of these because it would be really repetitive about stuff we already know. Okay, and you guys know how I feel about busy work, right? Don't like it. So, but we are going to have some conversations about this. We are going to fill in this part right over here. Okay, if I have look at my bases. Okay, I have a 2, a 3, and an 8. Just so you know, this is the 2, this is the 3, and this is the 8. Okay, so how do these graphs compare? First of all, the only thing that's changing is the b, right? The base. The only thing that's changing is the b. So how do these graphs compare? The a's are the same. Okay, so a's are equal. How else? It does look like they have the same y-intercept, and in fact, they do. And think about this. When x is 0, what would y be? If x is 0, what's 2 to the 0 power? 1. What's 3 to the 0 power? What's 8 to the 0 power? It's all 1, right? So when x is 0, y is 1. So remember, like in all of our other parent functions that we've dealt with, we always try to find that one place that we move around. With the parabola, it was the vertex. With an absolute value, it was the vertex. With the square root, it was that starting point, right? Well, that's the point we're going to move around because that's the one that's true for every parent that we can have. So what's a little bit different about exponential functions than any of the other functions that we've dealt with before is the fact that there's not just one parent. Okay? This is a parent, this is a parent, and this is a parent. So how are we going to talk about what's a parent and what's not? What makes this a parent as opposed to like 3 to the x power plus 1? Yeah, it's just the base and the exponent where the variable is, right? The base can change. And what, first of all, let's write what you said a minute ago. The x-intercept is the same. Excuse me, thank you. Y-intercept are the same. So what's different? What's the word we usually talk about when we talk about how these are changing? They're steeper, right? Here's the 2. Isn't the 3 steeper? Isn't the 8 even steeper than that? So the base, so b, can cause the graph to be steeper or not as steep. How about that? Does that work? Does that work for you while still using some good vocabulary? Okay, good. So what about set 2? What changes here? The b again, right? So guess what's happening here? If this one looks like this, is that what I want to say? Hold on real quick, because I think I just drew the wrong thing. But I want to be able to show you. You know what I'm saying? I always do mine in pen so you can see it. Don't say that. My window's all weird on my calculator. I don't know why. Okay, so if I tab and delete whatever equation's in there already. Whoa. Okay, so if I want to have... Seriously? What's it doing? Okay. If I want to have 0.6 raised to the x power. Oh, that is different, isn't it? How is it different? It's going down, right? So what's our math word for us to talk about when this is happening? Increasing, right? Okay, as x is increasing, y is increasing. What's happening here? Okay, so this is decreasing, right? So ignore the first one I drew. Sorry about that. This one's going like this. right? Still crossing at the point 0, 1, right? So what do you think the one that's 0.4 is going to look like? You ready to watch when I hit enter? So what's 0.1 going to do? Here we go. I'm going to hit enter. Watch. Okay. So there was the first one. Here's the second one. And there's the third one, right? This is 0.6. This one's 0.4. And this is 0.1. So first of all, how do they compare? Same y-intercept. Good. A's are equal. But once again, the B can cause the graph to be steeper or not as steep. Isn't it exactly the same as up here? Good. Uh-huh. That would be a very good way to say it. Say it one more time so I can say it. B's can cause the graph to change steepness. I'm okay with that. I'm not sure steepness is a word, but we all know what he means, right, when he says that? Okay? Okay. So, look at the base here. Okay? We definitely need to have a conversation about set 3. Look at the base. We need to talk about the number E. I know that for your whole life, you've been told that E is a letter. And that's because that's true. Okay? But E is also a number. Alright? Look on your calculator. Right here. See E to the x power? It's a number used so often that it's even stored in our calculator. Okay? So if I go to the scratch pad and let's just look at what E is. If I say E to the first power. Now first of all, that's rounded, just so you know. Okay? E is an irrational number, which means it cannot be written as a fraction, right? And so the decimals just go on and don't repeat, right? Okay? One of these days when we have a couple extra hours, I'll talk to you about where E comes from. And actually it doesn't take that long, so we'll take some time and talk about it, but just not today. I just want you to know that E is a number. It's not a letter this time. Okay? It's not a variable. Okay? So when we're talking about this, what's changing this time? The A. So A's this time are different. Yikes, my drawing skills today are not good. I'm sorry. So what's that causing? Are they all going through 0, 1? Not anymore. So what's A usually do? In all of our other transformation conversations, what does A usually do? Did they shift? Okay, remember A's usually cause a vertical stretch or compression, and since transformation rules work for all different kinds of functions, guess what change in A causes now? A vertical stretch or compression. Okay? No. Maybe. We'll talk about that later. How about that? Is that fair? Okay. So look at 4. A's change. How do these graphs compare? It's the A's that are changing again, right? So again, it's a vertical stretch or compression. But what's up with this one? Oh, because of that -2, right? So if A is negative, it does cause a reflection. Very good. Okay, so tell me then the difference between these and these. Because like these are increasing and these are decreasing, right? Even though this is flipped over, it's still decreasing, right? Kind of. Like if we think of it as flipped over the other way, it would be decreasing. Look at this base compared to this base. Do you remember what the value of E was? 2.71828-ish. So bigger than 2. What's true about this B? They're all the same, but they tell me about the value. This value is 2-ish. This one's 0.5. So thinking about other things that we've done, what if the value of the B, the base, is greater than 1? What's going to be happening? We're increasing, aren't we? What if the value is less than 1 but greater than 0? That's decreasing. Okay? Does that make sense? Alright, look at the next page real quick. Step 5. Here are the 3 equations that we're dealing with. Let's see. It's not very good, but you get the idea, right? It's actually very horrible. This one should be more like this. Where's it crossing? I wish I was doing a better job of drawing this for you today. This should be crossing at -1. Why? Well, it's normally here, but it shifted down 2, right? Where's this one crossing? This one should be crossing. It was at 0, now it's at 1. Sorry, it was at 1, now it's at 2. So this one should actually be up here. Gosh, I'm doing a horrible job drawing today. Hope you forgive me. And then we have the parent that's actually crossing at 1. So I did have one of them right. I just messed it up even when I was trying to fix it. So what's happening here? Do me a favor and tell me you understand what this means. It's a vertical shift. Okay? It's not, the base is not mattering, the multiplier out in front is not mattering. What's mattering is the fact that we have a +1 and a -2 outside of the exponent. Okay? So what's happening here? Okay, so all of them are up 1 somehow, right? But we have several different things happening. Maybe we have a reflection because of this negative, so we're not going to fill this in. Okay? This is the part that I really want filled in right here. This one right here. Okay? When our A is greater than 1, that is a vertical stretch. That's something we're used to, right? When A is between 0 and 1, what is that? Vertical compression. What about when A is less than 0? Very good. That is a reflection over the x-axis. Okay? So what about B, the base? If B is greater than 1, the graph increases. If B is between 0 and 1, it decreases. So what about K? If K is greater than 0? No. We're going to shift up. K, remember vertical, the k of that sound? What if K is less than 0? Down. And what's the most important part of this word right here? The F, right? Don't forget the F. What about if Y equals K? What's happening at Y equals K? Your favorite word. There's a horizontal asymptote there. So what are we missing? We have an A, we have a K, we don't have an H. Are we going to worry about horizontal shifts with exponential functions? No, but if we did, it would be right here. Right? In the exponent. Does that make sense? And if I honestly think if I gave you a problem like this, you would have no problem with it because you're used to something like that. Okay? So let's look at this graph right here. This is what's given. First of all, is A less than 0 or greater than 0? I say it's less than. Very good. Okay? Is B greater than 1, sorry, less than 1 or greater than 1? A flipped it over. If it was flipped back over, would it be increasing or decreasing? It would be increasing, so it is greater than 1. And what about K? Is it less than 1, sorry, less than 0, greater than 0, or equal to 0? Because it's crossing right there at 1, right? If it was flipped over, it would be at 0, 1, like parent function type of form. Okay? What about this one right here? What about A? What about the multiplier? Is it less than 0 or greater than 0? Greater. What about B? Is it less than 1 or greater than 1? Greater because it is increasing. What about K? That's probably 1 right there, isn't it? So K is probably greater. Yes, sir. Ask me. Uh-huh. Kind of. That's a very good question. Okay. Right now we're saying, is it flipping over or not? We're not really specifying what number it is to know if it's steeper or shallower. But A is telling us if it's, we're mostly just talking about is it positive or negative. Okay. Yes. Okay. Then B, we're talking about whether B, is it increasing or decreasing. We're not really getting in so much as it's steeper or shallower or something like that than apparent. Okay? Yeah, so what do you think it is on this one? On this one right here? Well, it's only less than or greater than. Yeah. Because while B is less than 1, because it's decreasing, it's still decreasing in this way instead of like upside down. Okay? And what about K? What do you think K is? Where is it crossing? Less than. Okay? So what I want you to do on this page right here, well, that's funny. Not in a good way, but we'll just go with this. I want you to do A, B, C, and D, these 4 problems on the back. Okay? So you're going to have to work a little bit with this table. So I want to give you a little bit of time at the calculator, be able to sketch the graph. So you might want to do all the calculator stuff first and then answer the questions later on. Okay? You have any questions?